Hey guys, we are graphing some absolute value equations today. Okay, cool thing about these is when we graph these, we have what we call our parent graph. Okay, so if you were just being asked to graph y equals the absolute value of x, this is what your graph would look like. Okay, but we are being asked to graph something that looks a little bit different. We are being asked to graph the absolute value of x minus 2. Okay, so it's going to be the same graph. It's just going to be changed a little bit. Okay, and to know what those changes are, we look here. Okay, so for this example, there is not a number out in front of my absolute value bars. But if you want to see an example like that, I will link one in the corner. But let me just tell you really quickly how that can affect your graph. So if it's a positive number, it's going to open up. If it's a negative number, your V will open down. Okay. Also, if it's a number like 2, 3, 4, 5, 6, it will stretch your graph. If it's a fraction, it will compress it. Okay, so it'll look a little something like this. That blue is the parent graph I showed you earlier. The green has a number out front of 4, right? And it stretches that graph. You see how it's like a lot skinnier? And the red has the 1/4 out front, and so it is compressed. Okay, so that is how that number can affect your graph. All right, but from there, if you have a number being added or subtracted inside of the absolute value bars, that tells you how your graph shifts to the right or left. Okay, and you actually do opposite of the sign. So if I had a +2 in there, I would go to the left 2. Okay, but obviously in this one, there's no number in there, which just means my graph's not going to shift to the left or the right. Okay, but I do have a number subtracted off the back, right? This number tells me how much my graph is going to be shifted up or down. And this one, you do stick with the sign. So that -2 means my graph is going to shift down 2. Okay, so let's see what that looks like. Remember my parent graph, the vertex was at 0, 0. I'm not going left or right at all, but I am going down 2. So this is my new vertex. Okay. Now, there's some teachers where all they really want to know right now is that you know where the new vertex is and you know it opens up, and they're not too concerned about your V being perfect, right? But you might have some teachers that do want an accurate V, right? So there's a couple ways we can go about this, okay? We're going to plug in some points to figure out what this V looks like, okay? So I want to know where it crosses the x-axis, which means I'm going to plug in 0 for y, okay? So we're going to have 0 equals the absolute value of x minus 2, okay? So I want x alone, so I'm going to add 2 to both sides. And I'm going to have 2 equals the absolute value of x, okay? If you need an absolute value review, I'll link one in the corner. But basically, this is asking for a distance, right? So to get the answer of 2, I know that the absolute value of 2 is 2, okay? Because it's asking for a distance from 0, and 2 is 2 units from 0, right? I also know that the absolute value of -2 is also 2, because -2 is a distance of 2 from 0. You can't go a negative distance, right? So I know that x equals 2, and it also equals -2, okay? So I got 2 when I plugged in 0 for y, and I also got -2 when I plugged in 0 for y, okay? So those points are here and here, okay? And as you do this more, you might get to know the parent graph well enough that you wouldn't even need to plug in those points, but we did it for now, just, for fun, because I bet you love plugging in points to equations, all right? So now I'm just drawing these straight lines to make our V. Okay, and so that is what this graph looks like, okay? All right, hopefully this made sense. If you need some more absolute value videos, I'll link a playlist in the corner for you. Thanks.